All right, today we're jumping into the world of manufacturing to talk about one of the most essential machines out there, the press brake. This is all about the century-long quest for, well, the perfect bend.
I mean, think about it. How do you take a solid sheet of steel and just bend it like it's a piece of paper? And not just bend it once, but do it with perfect precision thousands of times. That's the real puzzle we're digging into today.
And the answer isn't just one single machine. It's actually an evolution. It's this whole technological journey, and it's all been driven by the need to go faster, have more control, and achieve just flawless accuracy. So to really get a handle on this, we're going to break it down into three big eras of bending tech. First up, we've got the age of just raw speed. Then we'll move into the era of power and control. And finally, we'll land where we are today, focusing on incredible precision and efficiency. Okay, let's start at the beginning. Our journey kicks off with the original powerhouse, the mechanical press brake. This was a machine born in a time when momentum was everything. So how in the world does this thing work? Well, picture this. You've got a motor that spins up this huge, heavy flywheel. It's just storing up tons of rotational energy. Then, the operator hits the clutch, and bam! All that energy gets shot over to a crankshaft, which slams the ram down in one single, powerful, super fast motion. And right here, you can see the big trade-off. On the one hand, these things are incredibly fast. If you're just stamping out the same part over and over, they're amazing. They're simple, they're tough, but, and this is a huge but, the limitation is control, or really the lack of it. You can't change the force halfway through a bend, and trying to stop it on a dime, forget about it. It's almost impossible. This quote absolutely nails it. Think of it like a sledgehammer. It's incredibly powerful right at the moment of impact, but you can't just stop it mid-swing. All that force is dumped right at the bottom of the stroke. Great for simple, high-volume stuff, but a huge problem if you need any kind of flexibility or, safety. And that limitation, well, it's what led to the next big leap forward. So, where did the technology go from there? Well, that brings us to the workhorse of pretty much every modern fab shop, the hydraulic press brake. Welcome to the age of control. So instead of that big spinning flywheel, these machines use hydraulic cylinders. It's a totally different approach. By precisely controlling the flow of pressurized oil, they can push the ram down with a really steady, manageable force. And let me tell you, this was an absolute game changer. The biggest win here, versatility. You get full power anywhere in the stroke, not just at the bottom. You get modern CNC control, and they're way, way safer. So what's the catch? Well, a couple of things. The oil temperature can actually affect performance, and they do need more maintenance, seals, oil changes. Plus, they can be energy hogs because that hydraulic pump is often running even when the machine isn't bending anything. Yeah, and the bulldozer analogy is perfect. It's not about that one fast hit. It's about a strong, steady, and super controllable push. You can apply exactly the right amount of force right where you want it, and yeah, you can stop it on a dime. But what if you need even more precision? Well, that question brings us to the modern era, and to our third machine, the electric press brake. This is the specialist of the bending world, born and bred in the age of precision. Okay, so with these, we're ditching hydraulics completely. Instead, they use these super high-tech servo motors. We're talking the same kind of motors you'd find in a sophisticated robot, and they're connected to things like ball screws or belt drives. What this means is that the system can take digital commands and turn them directly into incredibly precise physical movement. The huge advantage here is just mind-blowing accuracy. Electric brakes give you exceptional repeatability, they're super fast on small parts, and they are incredibly energy efficient. Plus, they're clean and quiet. So what's the downside? Well, they usually don't have as much raw power or tonnage, and they cost more upfront. So they're not really the best choice for bending, super thick, heavy steel plate. And this chart really drives home one of the biggest selling points. Look at that. A hydraulic machine's pump is often just sitting there, running, burning energy even when it's idle. The electric brake? It only pulls power when it's actually moving. The difference in energy savings over time is just massive. So let's recap our analogies. If the mechanical brake is the sledgehammer and the hydraulic is the bulldozer, then the electric brake is definitely the robot arm.
Every single move is programmed, it's perfectly repeatable, and it's accurate down to the micron level. Just incredible. Okay, so we've got these three amazing but very different technologies. How on earth does a factory choose which one to get? It's about way more than just looking at a spec sheet. It's really about matching the machine to the mission. That really is the million-dollar question, isn't it? Is there one best machine out there? And the answer, as you've probably guessed by now, is a big no. It completely depends on what you're trying to make. And this table just lays it all out perfectly. Look, if your number one goal is just raw speed on simple parts, you go with a mechanical. If you need a machine that can do a bit of everything, handle different jobs, thicker materials, the hydraulic is your go-to workhorse. But if what you need is absolute maximum precision for really complex, tight tolerance parts, then the electric is, without a doubt, the specialist you call on. And that really is the most important thing to remember. There's no best machine in a vacuum. The best press brake is simply the one that perfectly aligns with a factory's entire manufacturing identity, whether that identity is all about speed, all about flexibility, or all about that uncompromising precision. So we've come this far. Where does the quest for the perfect bend go next? Well, the future is looking a whole lot smarter, a lot greener, and definitely more automated. I mean, we're seeing machines that are connected to factory-wide data platforms, giving you real-time tracking. We're seeing the rise of fully robotic bending cells, which absolutely demand the kind of perfect repeatability you only get from electrics. Sustainability is a huge driver, pushing for more energy efficiency and getting rid of hydraulic oil. And we're even seeing cool hybrid tech, like servo-driven pumps, that make hydraulic systems way more efficient. It all leads to this one final, really interesting question. As factories get smarter and these machines get more and more automated, are we heading towards a future where that perfect bend is made without any human touch at all? Definitely something to think about. Thanks for tuning in.